All right, let's dig in. Today we're talking about a story that's literally billions of years in the making. It's the rock cycle. And we're going to look at it through the lens of the two giant competing engines that power our whole planet. You've got the sun working from the outside and the Earth's fiery core working from the inside. We've all done this, right? You're on a hike, you're at the beach, you pick up some cool-looking stone, and you just wonder, what's its story? It seems so permanent, so simple, just sitting there. But here's the thing, that rock isn't static at all. It is caught up in a constant, massive process of creation, destruction, and transformation. It's a cycle that's been shaping our entire world for billions and billions of years. So, to really get this story, we first need to meet the main characters. There are three basic types of rock, and each one is formed in a totally different way. First up, you've got igneous rock. The easiest way to think about this? Volcanoes. This rock is literally born from fire. It's formed when that super hot magma from deep inside the earth, or lava once it's on the surface, cools down and gets hard. And what's really unique here is the process itself. Igneous rock is the only type that's formed by a loss of heat. Next, we've got sedimentary rock. You can think of this as the planet's ultimate recycling project. It's made from all these tiny little pieces or sediments of other rocks, minerals, even shells and plant matter. All that stuff gets broken down, carried away, and then squashed together over millions of years. This is why you see layers in rocks like sandstone, and it's also why this is the type of rock where we almost always find fossils. And our final player is metamorphic rock. The clue is right there in the name, morph, which means to change. See, these rocks start out as something else, igneous, sedimentary, whatever. But then, deep inside the earth, incredible heat and pressure basically cook and squeeze them so intensely that their actual chemistry changes. They transform into something completely new, like when limestone morphs into marble. So you've got these three kinds of rock, and they're always changing from one to another. But what is it that drives all this melting and squashing and transforming? Well, the answer is that our planet has two huge, incredibly powerful engines that are working at the same time. On one side, you have the sun's energy beating down, shaping everything on the Earth's surface. And on the other, you have the incredible heat radiating out from the Earth's core, churning and changing things from deep within. So one works from the outside in, and the other works from the inside out. Let's start with that first engine. Okay, this is the engine that we can actually see in action pretty much every day. Every time the wind blows, every time it rains, heck, every sunrise. That's the sun's energy at work, sculpting the world around us. And this solar-powered engine, it follows a pretty clear step-by-step process. First, it breaks existing rocks down into tiny pieces, then it moves those pieces somewhere else, lets them settle, and then basically glues them all back together into brand new sedimentary rock. Think about it. The sun heats and cools rocks over and over, making them crack. That's called thermal stress. It powers the water cycle, which brings rain that can chemically change rock. And of course, it drives the wind. All of that stuff breaks rocks down. That's weathering. Then, that same wind and water carry those little fragments away. That's erosion. And eventually drops them somewhere new, like the bottom of a lake. That's deposition. And that, in a nutshell, is the sun's engine. Now let's talk about the second engine. This one is totally hidden from us, operating on a scale that is just almost impossible to wrap your head around. Deep, deep beneath our feet. This is the raw power that comes from the planet's core. This internal engine is all about pure brute force. It drags rocks down into the earth, puts them under just unimaginable heat and pressure, sometimes melts them completely back into liquid, and then lets them cool off and reform as brand new rock. So the heat from the Earth's core makes the mantle, the layer beneath the crust, flow in these super slow-motion currents. And this moves the tectonic plates on the surface around like they're rafts on a thick, hot sea. That movement is what gives us volcanoes, builds mountains, and shoves rock deep underground. And down there, one of two things can happen. The rock can either get cooked and squeezed into metamorphic rock, or it can melt entirely into magma, which, as we know, cools to become igneous rock. So you've got these two engines, right? The sun is breaking things down up on the surface, and the Earth's core is building things up and changing them from way down below. So now, let's see how they work together to create this never-ending, really dynamic cycle. Okay, so here's the most important thing to get about the rock cycle. It is not a simple, neat little circle. It's really more like a huge, chaotic web of possibilities. There's no one set path. Any rock can get pulled into any process at pretty much any time. Let's just follow one of the countless possible journeys. So picture a piece of igneous rock. Let's say it's granite, fresh from a cooled magma chamber. So the sun's engine gets to work on it. Over thousands, maybe millions of years, wind and rain just hammer that hard granite, breaking it down into tiny little grains of sand. Right, so then those grains of sand get washed into a river, they settle on the bottom, and they get buried under more and more and more layers until all that pressure squishes them together into a new sedimentary rock like sandstone. But then, Earth's internal engine takes over. Tectonic plates shift, and that layer of sandstone gets forced deep, deep underground, where all that intense heat and pressure chemically transforms it into a totally new metamorphic rock, something like gneiss. And if that gneiss gets pushed even deeper, it can actually melt completely, all the way back into magma. That magma might eventually rise up to the surface, cool down, and crystallize, and boom, it's a new piece of igneous rock. The cycle is complete, and it's ready to start all over again. And that really is the magic of this whole system. I love this quote. It says it perfectly. Each rock kind of follows its own unique pathway through the rock cycle. I mean, that metamorphic rock could have been pushed back to the surface and weathered again. The igneous rock could have been remelted without ever becoming sediment. Each one has a totally unique story. So in the end, it really all comes down to these two incredible interconnected engines. The sun's power working on the surface and Earth's inner fire working deep below. They're in this constant, grinding, creative partnership. And it all happens on a timescale of millions of years. So slow that it's basically invisible to us, but it is happening all around us all the time. Every single mountain, every canyon, every little pebble you pick up is a piece of this incredible, powerful cycle. It's just a reminder that the solid ground we're standing on is anything but permanent. It's a story that is still being written, one grain of sand at a time.